Okay, so good morning. How are you today? How are you? It's Thursday. Still keeping? Yeah. Okay, so last 2 days. Tomorrow is Friday. Are you happy when it's Friday? Yeah. Okay. So yesterday, we have discussed already about biconditional statements, right? And what can you say about biconditional statements? From the word by. Yes, Noah? Biconditional statements. So we have the word condition, right? By. We have how many statements involved in the biconditional statements? We have two, right? So biconditional statements are two statements, okay? So we are using the word if and only if. We are combining the conditional statements and its converse, right? So the conditional statements involves the word if and then, where if is the hypothesis and then is the conclusion. Okay? And this time, for today, so we're going to discuss about deductive reasoning. Okay? So isn't it, we have discussed already about inductive reasoning. And what have you remember about inductive reasoning, Wendy? When you say inductive reasoning, what do you mean by inductive reasoning? These are reasoning based on what? Very good. Okay, Haley. So when we say inductive reasoning, these are reasoning that is based on patterns that we observe. On the other hand, when we say deductive reasoning, it is another type of reasoning wherein it is based on truths or statement. Again, when we say deductive reasoning, it is a reasoning that is based on statements or facts. Facts, it means true. To arrive a conclusion. So our conclusion here will be arrived through the given statements. It should be true statements. Okay? And when we say deductive reasoning, it is also called logical reasoning. Again, when we say deductive reasoning, it is also called logical reasoning. And we have two law on deductive reasoning. What are the two laws in deductive reasoning? The first one is the law of detachment. And the second one is the law of syllogism that we are going to discuss for today. Okay? So the law of detachment states that if the hypothesis of the true conditional is true, then the conclusion is true also. So in symbols, we can say that if P implies Q is true, and we have another statement here, P, or our hypothesis is also true, therefore we can say that our hypothesis, conclusion is also true. Again, so the law of detachment states that the hypothesis of the true conditional is true if and only if P is true and Q is also true. So it should be both true. Okay? So let's have example here. So problem number 1 on your book, page 107. So it states here, can you read, Haley, the example number 1?
If the student gives an A on a final exam, the student will pass the course.
Okay. What is our first statement? The conditional. we have if a student gets an A, so what's A? It's a grade, right? Okay, gets an A on a final exam, then the student will pass the course. So what is our hypothesis here? Noah.
A student gets an A on the final.
Okay, how about conclusion? What is our conclusion on our first statement, Daniel?
Then the student will pass the course.
Okay, so in our first statement, we have P. If a student gets an A on the final exam, then the student will pass the course. On the second statement, we have here our P. It says that Felicia got an A on her final exam. So therefore, based on those statements, does it tells true? Does the statement true? On the second statement? Yes. So therefore, we can say that, what would be our conclusion here? So as you can see, so the hypothesis of the first statement coincides with the hypothesis on the second statement. So we have here the specific name, Felicia. The name of the student is Felicia. So therefore, we can have our conclusion here.
Felicia will pass it straight.
Okay, that's correct. So that's Felicia will pass her history course. Okay, how about this example? If you are 18 years old, okay, if you are 18 years old, then you can register to vote. What is our hypothesis here? If you are 18 years old, then you can register to vote.
If you are 18 years.
Okay, if you are 18 years old, is it true? Yes. Then you can register to vote. It's also true, since it's just part of the hypothesis. Mary is 18 years old. That is the second statement. So therefore, what can you say, or what conclusion can you state on that statements?
Mary can register to vote.
Okay, that's correct. Mary can register to vote. Right? Mary can register to vote. Because Mary is already, how old is Mary? 18 years old. That is the law of detachment. Is it difficult? It's just easy, right? So it's just a matter of understanding the two statements. Then if the two statements are true, therefore we can create a conclusion. That is based on truth, because it's given. That's not based on pattern or, yeah, unlike in the inductive reasoning. Okay? Okay, example letter B. Wendy, can you read?
If a ray divides an angle into two congruent angles, and the ray is an angle bisector.
Okay. What is our hypothesis here, Noah?
A ray divides an angle into two congruent angles.
Okay, so the ray divides an angle to two congruent angles. And then the ray is an angle bisector. That is our conclusion. Okay, by the definition of angle bisector, does it satisfy the statement? Is it true? Based on the definition of angle bisector? That's correct. So therefore, our statement here is true. On the second statement, what is our second statement? Haley, can you read it?
Ray RS divides angle ARB so that angle ARS is congruent to angle SRB.
Okay, we have ray RS divides angle A or B. So we have here S, right? So we can say that it states that on the second statement that ray RS, we have ray RS divides angle ARB, this angle, an angle, what's the second angle? SRB. And it also says that it is congruent. Right? So therefore, what conclusion can we make on those statements, Amber?
That RS is an angle bisector.
Yes, ray RS is an angle bisector. Right? Okay? So what if we don't have here angle ARB and angle SRB, it didn't state that it's congruent. Can we conclude that ray RS is an angle bisector? Not totally. It should have the word congruent because we cannot say that they are congruent. We can say that it's an angle bisector, but we are not sure if they are congruent. Because as you can see, these angles can be divided, but we can have different measurement. Okay, how about this one? What conclusion can you make on this statement? If the measure of an angle is less than 90 degrees, then it is an acute angle. The measure of angle 1 is 85 degrees. Okay? If the measure of an angle is less than 90 degrees, then it is an acute angle. The second statement, the measurement of angle 1 is 85 degrees. What will be our conclusion with that statements? Noah. The first statement is if the measure of an angle is less than 90 degrees, then it is an acute angle. The second statement is the measurement of angle 1 is 85 degrees.
Angle 1 is an acute angle.
Okay, angle 1 is an acute angle. Right? Okay. Okay. Did you get it? Okay, so got it number 1A. If there is lightning, then it is not safe to be out in the open. That's our first statement. Got it number 1 on your book. Marla sees lightning from the soccer field. So what would be our conclusion here? What can you say about the conclusion based on the given two statements?
Marla is not safe to be out here.
Okay, Marla is not safe. Marla is not safe out in the open area or open. How about letter B? If a figure is a square, then its sides have equal length. Figure ABCD has sides of equal length. Do we have conclusion here? What would be our conclusion if
Figure ABCD is a square. Figure ABCD is a square.
is a square? Okay, on the first statement, what is our P? If a figure is a square, right? Then its sides have equal length. Can we say that figure is ABCD? Can we say that? That's a figure? Are you sure that ABCD is a square?
It says it is. Equal length.
Okay, ABCD has sides that are equal length. So therefore that's a square. Okay, so the answer would be
Figure
Okay.
ABCD is a square.
a figure, what's your answer?
Figure ABCD is a square.
Okay, figure ABCD is a square. Okay. Okay, so it's just the law of detachment. Okay. Next, the second property. So we are done of the first property. We have the law of detachment. So it's just P implies Q. P is true, then Q is also true. So the law of syllogism states that if P implies Q, then Q is also true, then P implies R is also true. So we have here how many statements? In the law of syllogism, how many statements do we have? So here we have two statements only, then we can arrive already on a conclusion, right? But in the law of syllogism, we have here three statements, okay? Okay, so let's have here example. If it is July, then you are on summer vacation. If you are on summer vacation, then you work at a smoothie shop. So what is our first statement here? What is our P on our first statement?
It is July.
Okay, it is July. That is our hypothesis. How about Q, Amber, or conclusion on our first statement?
You are on summer vacation.
Then you are on summer vacation. How about on the second statement, Haley?
Wait, what's the question, sorry?
Hmm?
Wait, what are you on about?
What is the R factor?
Or these are the statement. These are just the statements. We have three statements. So we have P, the first statement, that's hypothesis. We have Q, that will be the conclusion. Then R is just the third statement. Okay? So we have the second statement.
You are on summer vacation.
Mm-mm. Then you work at the smoothie shop, right? So that would be our third statement. So as you can see, what can you observe on the statement? First two statements. What can you say about the first two statements on our example?
It is July, and you work at a smoothie shop.
Okay, as you can see, we have same, right? Same Q. Okay? The conclusion of the first statement, isn't it? What is the conclusion of the first statement? You are on the summer vacation, right? The conclusion of the first statement is the hypothesis of the second statement. Again, the conclusion of the first statement is the hypothesis on the second statement. So therefore, we can cancel out. We can cancel out Q here. Right? So that's why we have here the conclusion P implies R, or the third statement. So therefore, what would be our conclusion here? Wendy,
For which question?
if it is July,
If it is July, then you work at a smoothie shop.
okay. Okay, another example. Have you tried shopping on the Walmart? You went to Walmart?
Yeah.
Okay, do you have the card? Okay, for example, these are the statement. If you shop at Walmart, then you will use your Walmart card. That is our first statement, right? If you shop at Walmart, then you use the Walmart card. The second statement, if you do not use the Walmart card, then you will get discount. Does it satisfies the law of syllogism?
No.
Why? Very good. Okay? The hypothesis of the first statement, the conclusion of the first statement must be satisfied with the hypothesis of the second statement. Because the example is, if you did not use, right? If you did not use the Walmart card, then you can get a discount. So what should be the statement to make it to have a law of syllogism?
If you use the Walmart card, then you get discount.
Okay, if you use a Walmart card, then you will get a discount. That's an example of, okay? So we have here problem number 2, so letter A. So if a figure is a square, then the figure is a rectangle. We just observe on the hypothesis, the conclusion, right? And then on the second statement, we have here, if a figure is a rectangle, then the figure has 4 sides. So therefore, does it satisfies in the law of syllogism? Yes, so we can have cancellation here. So we have P. If then the figure is a rectangle, so we can cancel it out. So our conclusion here would be, if a figure is a square, then the figure has 4 sides. Okay? Okay, gadget number 2. Can you conclude what would be the conclusion? Number 2A. 2A. It says here, if a whole number ends in 0, then it is divisible by 10. That is our first statement. The second statement, if a whole number is divisible by 10, then it is divisible by 5.
If a whole number ends in 0, then it is divisible by 5.
Okay, does the conclusion of the first statement satisfies with the hypothesis of the second statement? Yes, so therefore we can have our conclusion here. Okay? The conclusion would be, if a whole number ends with 0, then it is also divisible by 5. Is it true? That if a number ends with 0, then it's divisible by 5. That's correct. So that satisfies our law of syllogism. Okay? Because it must be true. Because if the statement or the conclusion that you make from those statements is not true, therefore there's something wrong. So it should be true. Because our conclusion is based on the statements. Okay? That's logical reasoning. Okay? Question? How about this example? If it is raining outside, then there are clouds in the sky. It is raining today. It's our third statement. Again, if it is raining outside, then there are clouds in the sky. It is raining today. What is our conclusion on the first statement? If it is raining outside, then there are clouds in the sky. That is our first statement. What is our conclusion? There are clouds in the sky. And the second statement is, it is raining today. What law can we apply here? Is it law of detachment or law of syllogism? Detachment, because we just had 2 statements here, right? So therefore, can we have a conclusion? What would be our conclusion?
It is, there are clouds out today.
Okay, there are clouds today, or there are clouds in the sky. You can just say that. How about this one? If Noah scores at least 85% on his final exam, that is the first statement, then he will earn an A for the term. Noah scores a 90% on his final exam. What law of deductive reasoning is used on those statements? Okay, law of detachment. Law of detachment? Okay, again, if Noah scores at least 85% on his final exam, then he will earn an A for the term. Noah scores a 90% on his final exam. Is it law of detachment? Yes, because we are just having two statements. So what would be the conclusion? Noah got a score of 90% on the final exam.
No, pass.
Hmm?
Pass.
Noah will pass the term? Yeah. Or Noah can earn an A in the term, right? Because it's given on the first statement that if you score at least 85% on the term, then you will earn an a grade of A. And what's the meaning of A? What's the equivalent for A? At least 85%?
No,
It's 90?
92.
Yeah, but this is just an example. Okay, so it's given that at least 85% you will earn an A. Then, since you get a 90%, therefore you get an A on the term. That would be our conclusion. Okay, problem number 3. Okay, using law of syllogism and detachment at the same time. Okay, combination of detachment and syllogism. On those statements, then we will arrive at a conclusion. Example given here, if you live in, is it Accra? How do you pronounce it well? Yeah, do you know Accra? What's that? Hmm?
It's in Africa.
It's in Africa, right? Is it a city? Yeah, it's, as you can see, there's a map here, right? Okay. If you live in Accra, then you live in Ghana. Is it Ghana? And what is Ghana? Okay, it's a country in Africa. I think Accra is a city in Ghana, right? It's a city. I'm not sure. Okay, it's a city in Ghana. Then the second statement: if you live in Ghana, then you live in Africa. Isaiah lives in Accra. So what is our the first statements here? If you live in Accra, then you live in Ghana. Can you identify the statements that satisfies the law of detachment here? What are the statements that satisfies the law of detachment? Yes, Linya?
If you live in Accra, then you live
Okay.
in Africa, and then Melissa lives in Accra.
Okay, the first two statements, if you live in Accra, then you live in Ghana. So the conclusion is you live in Ghana, right? And then the second statement, if you live in Ghana, that's our hypothesis. Therefore, we can cancel it out. Okay? So therefore, our conclusion here would be what? So we have here the last statement. Isaiah lives in Accra. So therefore, this is Isaiah. So the conclusion here would be Isaiah lives in Africa. Because those places that is involved on those statements are just part of the African country, right? So we can just have the conclusion based on one. What would be the conclusion for this? If you live in Westminster, then you live in Carroll County. If you live in Carroll County, then you live in Maryland. Daniel lives in Carroll County. What would be the conclusion? First statement, if you live in Westminster, then you live in Carroll County. If you live in Carroll County, then you live in Maryland. Daniel lives in Carroll County. What would be the conclusion?
Daniel lives in Maryland.
Daniel lives in Maryland. That's the statement. So what law of deductive reasoning we use on those statements? Noah. Is it law of detachment or law of syllogism? Yeah, it's syllogism because the conclusion of the first statement, isn't it? You live in Carroll County is just the hypothesis of the second statement. That if you live in Carroll County, then you live in Maryland. So therefore, our conclusion is Daniel lives in Maryland because it satisfies our law of syllogism. Okay? Question. Do you have any question? So is it difficult to identify the conclusion? Yeah. So when you say deductive reasoning, it's just we are arriving at a conclusion based on the given statement. It is based on facts, true statements. Unlike in inductive reasoning, we are just looking at the patterns to arrive at a conclusion. Okay? So that's the difference between inductive and deductive reasoning. Okay. Number 3A. Got it. What would be our conclusion here? If a river is more than 4,000 miles long, then it is longer than Amazon. Do you know Amazon? What's Amazon? Is that where you shop? No?
It's a long river.
Yeah, it's a long river. So here we can just say that Nile is the longest river in the world. That would be our conclusion. Nile is the longest river in the world. Okay, so have a good day.
Do we have any homework tonight?